Hi everyone. I hope you're having a great day so far. We're on Big Ideas lesson 8.5. So in OneNote, 8.5, tap print out, and then you'll get your page that you can look at, your book pages. Mine went to the bottom for some reason. May have been where I had it open last. So we're going to go up to the top, 8.5, using intercept form. Yes, indeed, we have another form of a quadratic equation. But once we see what this one looks like, I think it'll be pretty easy for you. So what is our learning target? To graph and use functions in intercept form. You'll be able to graph quadratic functions, and this is the form that is intercept form. You'll be able to find zeros of functions using intercept form. And then we actually, and use characteristics to graph and write quadratic equations, not cubic functions. We don't do those. So, excuse me, graphing and finding the zeros we'll be doing on day 1. Graphing and writing using characteristics you'll be doing on day 2. So this lesson will cover today and tomorrow. All right. So let's just remind ourselves of our 3 forms because they will be very, very important. We have standard form. Think about it. See if you know what it is. F of x or y equals ax squared plus bx plus c. And then we have vertex form. F of x or y equals, think about it. Do you know what it is? A times x minus h squared plus k, where h comma k is the vertex. Well, the last one that we're going to do today is intercept form. And now we're going to add 2 more variables into things, but I don't want you to get fixated on them because I think that you will quickly see this is just like something else we've been doing. F of x equals a times x minus p times x minus q, where p and q are x-intercepts. All right, well, we have talked about x-intercepts a lot. I mean, like for every single lesson. And we know, we've talked about this a lot too, we have some vocabulary where zeros is the exact same thing as roots, is the exact same thing as solutions, is the exact same thing as x-intercept. So if we think about it this way, and we know that we find zeros and roots from, or solutions from a factored equation, that's all that intercept form is. F of x equals a times x plus p times x minus q. This is factored. Okay, so all intercept form is once you have factored, if it fits this pattern where you have an a greatest common factor you've pulled out, or it might be 1, so you may not have that, and you have 2 binomials, x minus p, x plus q. And of course, they could be x plus q and x plus p also. That just means that your p and your q are negatives. So all that factoring we've done, we can actually say that we can graph directly from factored form. And if we see it like that initially, before we've gone from standard form and factored it, then we call it intercept form. So hopefully it won't be too confusing. We're going to scroll down to where example 1 comes in. Graphing from intercept form. And it tells us we've already graphed from standard form. We've already graphed from vertex form. And now we're going to graph from intercept form. Now it gives you a little extra information here. I'm actually going to not underline it. It tells us A cannot equal 0. Well, what would happen if A equals 0? If A was 0, then everything multiplied by A would be 0, which means this would just say Y equals 0. So we know that that is not the case. I would not worry about A doesn't equal 0 too much. So it says in this form, the polynomial that defines a function is in factored form, and the x-intercepts can be easily determined. Okay, so intercept form equals factored. And that means it's something we already know. So this lesson shouldn't be too tough. Here's the key idea. If we take this with just our variables, which I know it's difficult to look at, but some of the things we want to know from intercept form is our x-intercepts are p and q. And we know that based on the factoring that we've done. When we set this equal to 0, we're going to say x minus p equals 0, so x equals p. And x minus q equals 0, so x equals q. So right away we can look, and whatever p is and whatever q is, we can graph those as our intercepts. The axis of symmetry is halfway between the zeros. Okay, if we're dealing with a quadratic function, our axis of symmetry is halfway between two zeros. Now, if there's only one zero, that throws a whole nother wrench into it. So we won't worry about that. We're going to assume we have two zeros when we're dealing with intercept form, and that halfway in between is our vertex. Now, you can just, look at the graph and count if you wanted. Algebraically, we do P plus Q divided by 2. Okay, so that's the axis of symmetry halfway. We're just taking the average. We're adding them, dividing by 2. So that would be our axis of symmetry. We already know the graph opens up when A is greater than 0, when A is positive, and we know it opens down when A is less than 0 or negative. And then it tells us one more thing, which we should already know, is that the x-coordinate of the vertex is the same as the axis of symmetry. So we know that. And then in order to find the rest of the vertex, we just plug that x value into the original equation, and we find that vertex. So I think those are things we've already done. So there'll be more repetition and practice, so we're sure we understand. Quadratics are probably the most important concept in algebra for you to know how to work with and remember for your EOC and future years in math. Okay, here we are at example 1, and we're going to see how to graph this equation that's written in intercept form, and we're going to find the domain and range. Hopefully, quadratic function, you already know what the domain is. Okay, first things first, identify the x-intercepts. I'm going to say it again. I won't write it this time. Zeros, roots, solutions, x-intercepts, they're all the same. When y equals 0, whatever x is, those are the solutions, those are the zeros, those are the roots, those are the x-intercepts. So if our equation is negative x plus 1 times x minus 5, first of all, with our negative, and change colors here because I should have pointed this out first, we know that this is going to open down. And then x minus 1, I want to change my color. X minus 1, sorry, x plus 1, x minus 5, P and Q, those numbers that are in there, are equal to the x-intercepts. So if we're looking, I'm just going to come over here for a quick second. If we're looking at x minus P, and this says x plus 1, then x must equal negative 1. And if we're looking for x minus q, and this says x minus 5, then x equals 5. So our intercepts are negative 1 and negative 5, and let me tell you, it does not matter p and q. They are just placeholders. So we go ahead and graph our zeros at negative 1 and 5, and those are on the x-axis because they are x-intercepts. The y value is 0. Next, our axis of symmetry. We're going to find the middle between these. Now, if you wanted to go down here to your graph and you wanted to say 1, 1, 1, 1, 1, 1, you could find that axis of symmetry. Okay, but maybe you're asked to do this once where you don't actually have the graph in front of you, where you have to do it algebraically. So we find the middle point, we find the average. So we add the two of them and divide by 2. Negative 1 plus 5 equals 4 divided by 2 equals 2. So that means we have an axis of symmetry at x equals 2. And then step 3, we're going to find and plot the vertex. Well, we see our axis of symmetry, so we know that our vertex is somewhere along that axis of symmetry. So we know that the x value is 2. So what we're going to do is plug 2 back into our equation and see what we get for f of x, or y. So we say y equals negative 2 plus 1 times 2 minus 5. And that's my original equation from up in the top of the problem. Now, I'm going to distribute my negative first. Negative 1. This is kind of like an invisible one here. Negative 1. Oh, I'm going to confuse you with that. Times 2 is negative 2. Negative 1 times 1 is negative 1. And then we have 2 minus 5. Negative 2 times 2 is negative 4. Negative, oh, don't do that. We don't have variables in here, so we can solve this. Oh my goodness. Without distributing. Negative 2 minus 1 is negative 3. 2 minus 5 is negative 3. And negative 3 times negative 3 is 9. So that means our vertex is at 2, 9. Right here. Vertex. Once you have your vertex and your 2 intercepts, then you can graph the parabola. You want a nice smooth line that goes through all 3 points. Then, remember, it wanted us to list our domain and range. Hopefully you know that domain is all real numbers. And the range has to do with our vertex because we look and see where's the absolute top of our graph. It's never going above that. So y is less than or equal to 9. Graphing from intercept form or factored form. Find the x-intercepts. Note which way the graph opens, up or down. Find the axis of symmetry halfway between those x-intercepts. And find the vertex by substituting back in the axis of symmetry for x. Okay, graphing. We're not in intercept form right now, but maybe we can get there. And they want us, of course, to find the domain and the range. So I'm going to make my background graph paper, and I'm going to come over to the right side and graph it. Okay, so our problem is, what color? I'm going to use purple. F of x equals 2x squared minus 8. We want to graph and find the domain and range. So the first thing I'm going to look at is, can I factor this? Yes, I can. So first we look for a GCF. Is there any number that 2x squared and 8 have in common? 2. So we factor out 2. 2 times what is x squared? Sorry, 2 times what is 2x squared? X squared. 2 times what is negative 8? Negative 4. Now, I want you to look at this for a minute. You should know that that is a special pattern. What is that special pattern? That is the difference of squares. So we can factor using difference of squares. X plus 2, x minus 2. We didn't have to do any extra work. We didn't have to do a lot of extra thinking. That is what is so great about those special patterns. Now we're in factor form or intercept form. Okay, this is intercept form. So what do we know about intercept form? We know that these numbers are going to be our x-intercepts. But remember, it's x minus p and x minus q. So this says x plus 2, so that's really x minus negative 2. And this says x minus 2, so that means x is 2. So our intercepts are 2 and negative 2. Which way does this graph open? Well, A is positive, so this graph is going to open up. So we have our x-intercepts. Now we want to find our vertex. So we're going to find halfway between P and Q. Negative 2 plus 2 divided by 2. It's like we're finding what's in the middle. Well, negative 2 plus 2 is 0, and 0 divided by anything is 0. So the x value of our vertex, or the axis of symmetry, is 0. We plug that back into our equation. You can use the top part, you can use the partially factored, you can use the fully factored. It's entirely up to you. I prefer to use the original equation because looking here, it's not going to take that much work. So I am going to set x equal to 0. And I knew that by multiplying all that stuff, all that was going to be is 0. So it's 0 minus 8. So our vertex is 0, -8. So now I have my x-intercepts, I have my vertex. Those are the things that I am going to want to use to graph. I know that I need to have some negative numbers in my y-axis. I don't really need positive ones because it only goes up to 0. And then I need some negative and some positive on my x. So I think that I will draw my x-axis here and my y-axis with mostly negatives. All right, so my x-intercepts, -2, +2. I know it's going to open up and it appears that way. 0, -8. 1, 2, 3, 4, 5, 6, 7, 8. This is very skinny. It's going to be really hard to make it not pointy at the end. So we sketch our smoothly curved line. It's always hard for me to change directions. And there is our graph of f of x equals x, 2x squared, 2x squared minus 8. We can compare it to what the book did. Looks pretty similar. Okay, we're going to do one more today. And I actually don't love the way the book set this up. I wish we had done this one first. I suppose I could have done it first. But finding zeros of a function, well, we just did this. It told us that in intercept form that P and Q are x-intercepts. Well, why? We know that at an x-intercept, whatever we have on the x-axis, that y equals 0 because it's not going up or down at all. We also know that y is our f of x. And we have found zeros or solutions using factored form. So instead of just relying on trying to memorize P and Q are the x-intercepts and that there's negative signs, so sometimes you have to think about the opposite, well, just solve it like you normally would. So here we have the vertex form f of x equals x minus 1 times x plus 2. Well, if we want y to be 0, then we set this equal to 0. And we know that if we're multiplying two things and our answer is 0, that at least one of those two things has to be 0. So that's where we fall to our zero products property. X minus 1 equals 0, x plus 2 equals 0, x equals 1, x equals -2. Okay, and those are our zeros, our roots, our solutions. When we're graphing, they are our x-intercepts. Okay, so we already knew how to do that, and it shows us how it applies to another form of our equation, which we kind of already knew about also, but in a different, with a different name. Your assignment is on Big Ideas. It is lesson 8.5, day 1, and we'll do day 2 tomorrow. Best of luck. Have a great rest of your day.